Welcome to the Kentucky Education and Labor Cabinet's presentation on the health hazards of welding. This presentation is designed to assist you in complying with occupational safety and health regulations. Because of the variations that occur due to on-site conditions or performance criteria, it is impossible for any course to cover every aspect of those potential variations. Therefore, this training does not cover everything a person should know about a particular subject, nor does it qualify anyone as a competent or qualified person. However, our course do cover part of this information that any person must know to be effective in applying safety and health standards and practices to circumstances in the workplace. This presentation covers the typical health hazards associated with welding. The presentation will communicate a general and basic understanding of welding, relevant occupational safety and health administration standards, common hazardous air contaminants associated with welding, and typical hazard prevention methods and controls. Topics covered during the course of this presentation will include definitions related to welding and welding hazards, Kentucky occupational welding statistics, specific occupational and health welding regulations, common air contaminants associated with occupational welding procedures, and ways to control a variety of health hazards when welding is performed. Welding consists of a variety of high heat processes which join metals together. Filler metals are heated and added to base metals to create welds. Fumes are a byproduct of the welding process. Fumes are formed as metal becomes volatile and condenses into the air. OSHA sets permissible exposure limits which regulate the maximum amount of chemicals from fumes an employee may be exposed to as they work. Employees familiar with welding or who perform welding operations should be familiar with these terms. It is important to recognize and understand the specific processes of welding being performed either at your establishment or by your employees. There are several types of welding. Typical types of welding include brazing, gas welding, arc welding, and resistance welding. Arc welding is a commonly used process and can be categorized further into MIG welding and TIG welding. MIG and TIG welding processes use either a metal inert gas or tungsten inert gas to form an electric arc with the base metal to create welds. Gas welding relies on fuel gases to provide the heat for welds, and brazing typically deals with metals with lower melting points. The data and information presented here illustrates the presence of employees performing welding activities in the state of Kentucky. The information here is only a general representation of the industry. Common compliance citations related to health hazards for welding emphasize the use of personal protective equipment. It is important for employees to understand that welding can produce serious health hazards and adequate controls and prevention methods should be implemented and followed for their safety and well-being. The Federal Occupational Safety and Health Administration has several regulatory standards for general industry in place related to welding work activities. Some of these OSHA regulations are specific to welding activities and detailed in their language, while others are broader but still applicable in scope. Federal OSHA also has several regulatory standards for construction in place related to welding activities. If you're an employee who works or may work on construction sites or perform construction activities, it is important that both you and your employer understand the regulations that govern the safety of your establishment or work site. OSHA's regulations define construction work as construction, alteration, and/or repair, including painting and decorating. Metals and gases can both be sources of air contaminants when heated or used during the welding process. Shielding gases can also be sources of air contaminants. It is important for employers and employees to not only be aware of the gases used as fuels, but also those used for shielding. The following are general hazards related to exposures to the contents of some shielding gases. Helium, nitrogen, and carbon dioxide are all gases associated with welding, which at high levels can displace oxygen in the blood. When oxygen is displaced, vital organs can be denied the oxygen they need to function properly. The displacement of available oxygen in the blood can also lead to headaches, dizziness, fatigue, or even a loss of consciousness. High levels of argon can also displace oxygen in the blood and decrease the available oxygen. Exposures to argon can also irritate or burn the skin and eyes. The following are general hazards related to exposures to some welding byproducts. Carbon monoxide displaces oxygen in the blood and can lead to a loss of consciousness and suffocation. Early symptoms of carbon monoxide poisoning can include headache, fatigue, dizziness, or nausea. Prolonged exposures to carbon monoxide can worsen these symptoms and increase the likelihood of losing consciousness. Ozone can result from the ionization of the air surrounding arc or high voltage. Exposures to ozone can cause headaches, coughing, shortness of breath, or fluid in the lungs. Prolonged or elevated exposures to ozone can intensify symptoms, and chronic exposures may lead to asthma. Employers and employees should be aware of the hazards associated with their welding work processes. Some typical potential health hazards are listed here, but may not encompass the full range of hazards for your specific process or procedures. Common health hazards across a variety of welding processes include potential exposures to ultraviolet light, high levels of noise, high levels of heat, and hazardous air contaminants. The following slides discuss some of the more common chemicals and air contaminants that are often associated with welding fumes. Several exposure levels are also listed on these slides. The exposure levels represent the limit an employee can be exposed to when working with these air contaminants. Antimony is sometimes coupled with lead to improve its durability and is a common byproduct of soldering and brazing processes. Beryllium has a specific OSHA regulatory standard. If an employee is exposed to beryllium, the requirements detailed in 1910-1024 General Industry and 1926-1124 Construction would need to be followed. Common occupations with potential exposures to beryllium are foundry laborers, furnace tenders, metal fabricators, welders, abrasive blasters, and dental technicians. Cadmium also has a specific OSHA regulatory standard. If an employee is exposed to cadmium, the requirements detailed in 1910-1027 for general industry and 1926-1127 for construction would need to be followed. Cadmium is commonly found during the manufacture of batteries, solar cells, electroplating, and silver soldering. Chromium is used in stainless steel and chrome plating, steel manufacturing, paint pigments, leather tanning, and some heat-resistant applications. Hexavalent chromium has its own specific standard, 1910-1026 for general industry and 1926-1126 for construction. The levels of hexavalent chromium an employee can be exposed to are very low compared to other welding fumes. Employees that weld stainless steel should be aware of hexavalent chromium and follow the necessary protective procedures to mitigate risks and potential overexposures. Workers may be exposed to cobalt when using cutting and grinding tools or working with colored glass, batteries, or performing some electroplating processes. Iron oxide is most often found as the feedstock for the steel and iron industries during the production of iron, steel, and other alloys. Most individuals should be familiar with lead. It has often been connected to gasoline and paints, but lead can also be involved during welding processes. Lead has its own specific standard, 1910-1026 for general industry and 1926-1126 for construction. Lead is still common in many industries, including construction, mining, and manufacturing. The primary use of lead in the United States is automotive lead acid storage batteries. Workers most at risk of being exposed to manganese often perform welding tasks. Manganese is used in the production of steel and alloy metals as a catalyst, a gasoline additive, and a component for some fertilizers. Molybdenum is found in the production of structural alloys and is used as a catalyst in its production. Nickel is involved in the manufacture of alkaline batteries, stainless steel, as an alloy and catalyst, and in electroplating. Vanadium is often used in manufacture of steel alloys, vanadium compounds, and synthetic rubber. Zinc oxide fumes can be present when zinc metals or zinc alloys are heated to high temperatures, such as in welding or galvanizing. Ultraviolet radiation is a form of non-ionizing radiation and accompanies much visual light. UV radiation is particularly hazardous because there are usually no immediate symptoms of excessive exposure. Protective barriers, as well as adequate welding helmets or eye protection, are important forms of control to protect employees working in adjacent areas where arc welding may be performed. Occupational noise can be any sound in any work environment. The process of welding creates noise on its own, but employees' work environment can also create significant levels of noise. Noise-induced hearing loss is one of the most common occupational illnesses, and it usually develops over a long period of time. The effects of excessive noise exposure worsen when workers have extended shifts longer than 8 hours. It is important that both the employer and employee work towards eliminating or reducing potential health hazards an individual may encounter when performing welding activities. The three main categories of control methods are engineering, administrative, and personal protective equipment. Engineering controls for welding activities are the best controls to implement for reducing exposures to potential health hazards and are often focused on ventilation. Providing employees with adequate ventilation is a key factor in preventing potential exposures to hazardous air contaminants. Employers and employees should perform regular checks on their ventilation systems. Maintenance should also be involved in performing preventative maintenance on HVAC systems, filtration systems, and exhaust systems. It is encouraged for a preventative maintenance schedule to be implemented at establishments where ventilation is a main means of eliminating or reducing exposures to hazardous air contaminants and related health hazards. Proper training on the use of welding equipment, potential hazards of welding, hazards associated with the material being used, and proper use of any available control methods should be implemented and reviewed regularly. Personal protective equipment, PPE, is often considered the last line of defense for potential hazards. PPE is used, it is important that it directly addresses a potential hazard and that the employee is trained on their equipment's use and function. Welding activities often require a wide variety of PPE, and it is important for employees to be fully trained and understand how all the PPE should be used to prevent hazards. There are many hazards associated with welding that can be obvious to practice welders. It is often easy to overlook or underestimate the harm potential exposures to welding air contaminants can cause to an individual's health. Being aware of the air contaminants in your workplace can assist in developing and implementing adequate controls and safeguards. Awareness of hazards is a foundational step to protecting your health and working safely and effectively. On this slide, I provided links in the form of QR codes that will take you to OSHA.gov for more information. Thank you for viewing this presentation. For more free safety and health online learning opportunities, please visit kysafe.ky.gov.